today we'll be looking at the two types of circuits, series and parallel. We'll be doing simple circuits with them, and we're going to be using Arduino to do so, but we're only going to use it for its power source. We're not adding any code to our projects yet, so we'll be just fine. So the first thing we're going to do is we're going to log into Tinkercad, and we'll be met with our home screen, and we're going to go to Create Circuits. So I like using a CAD software to begin with whenever I design things, because it lets me know how it will look, kinda, and what I should expect as far as struggles with it goes, and it will also tell me if a component works or not, which I think is pretty cool. So we're going to start by doing a really simple series circuit. So let's go ahead and drag in an Arduino. I'm going to press R to rotate it to how I wish it to be. I'm going to zoom in a wee bit. All right. And then I'm going to drag in my breadboard, rotate it as well, and drag it to where I want it to be. Okay, so first things first, let's go ahead and energize our breadboard. We're going to do that by dragging a wire from the ground to the negative. I'm going to change this wire to black. We're going to go from the positive, from the 5 volt, my bad, to the positive, and we're going to make this wire red. There we go. All right, simple enough, right? So we've just energized our power rails. Now remember, the negative power rail is energized all up and down, and the positive power rail is energized all up and down, but our rows are energized side to side. So let's go ahead and drag in a resistor. Because this will be a simple circuit with an LED, we don't want to put all 5 volts through an LED, so we're going to use a resistor to slow down some of that current. I'm going to take my resistor, plug it into the positive rail, and then plug it into, it looks like I'm on A5. Click on it, and we're going to change the resistance to 220 ohms. A lot of small things like LEDs and itty bitty motors and buttons, they work just fine with 220 ohms. Too much, they'll pop or burn out or explode, and that's not something that we want to happen right now, or ideally ever, unless that's your goal. Sometimes it is. Okay. So in this diagram, I want to have 2 push buttons. So I'm going to drag in my first push button. And if I keep it like this, with the legs on the top and legs on the bottom, then what I'm essentially creating from terminal 1B to terminal 1A is a wire, because these legs are connected. So what I want to happen is I want to be able to press the button and then the light turns on. Elseways, what's the point, right? So I'm going to rotate 90 degrees such that my legs look like this. And then just for the fun of it, I'm bringing a second one and I'm going to do the same thing. All right. So now, disclaimer, in CAD, what I'm about to do won't work, because in order to run the circuit, you need to press both buttons at the same time. You can only press one button at a time in CAD. So we'll look at how this works whenever we get to the physical build. All right. So I'm going to drag a jumper cable from B5 to A7, and that's going to connect it to this terminal leg of the button. Then I'm going to drag from A9 to A12, and those will connect those 2 legs. And then from A12 to A18, that connects it to the leg of the LED. And finally, we're going to go from the leg of the LED to the ground. All right, let's change these colors a little bit. I want these to be, let's make them purple. Alrighty, there we go. Now I'm going to make my ground wire black, just to stay consistent with ground. And if we run our simulation, nothing will happen because we can't press both buttons at the same time. But we will look at this whenever we build the physical one. If we want, we can remove this button, just move it over here. Get rid of, oh my goodness. Get rid of this wire, get rid of this wire, and then just drag from our resistor to our button. And whenever we press play, Oh, it doesn't work. So what's the easiest thing to do here? That's right, flip the LED. So let's select our LED and mirror it by pressing M. Then we'll run it again. And it lights up whenever we press our button. Now, there is the anode and the cathode on it. I'm not going to lie. I've been doing this for a long time. I still forget. So, as far as I'm concerned, if it doesn't work the first time, just flip the LED. That's my best debugging technique, besides talking to the duck. All right, so we're going to stop the simulation, and we're going to actually zoom out a little bit, scroll over a little bit, and we're going to drag in another Arduino. So let's go ahead and rotate this to where we need it. And with another Arduino comes another breadboard. All right, so the first one we built was a series. We call it a series pretty much because everything falls into a singular line. It's one after the other. It's a series. Kind of like how serial data is one bit after another. So we're going to zoom in here. Let's go ahead and set up our power. We'll do 5 volts to positive, and we'll do our ground to our negative. Let's go ahead and change those colors. Our ground becomes black, and our 5 volt becomes red. Alrighty. So, with this one, it's a little bit different, but we're going to start kind of the same way. We're going to have a resistor. Let's go ahead and drag that in. We're going to rotate and put it right there. All right. Resistor will be 220. Oh my goodness, that's too much. 220. Just regular ohms. And we will then drag in our buttons. Now, these buttons we're going to do a little different. We're going to make them bridge the gap right here. It won't really affect performance. We're mostly just leaving room for our jumper cables. Okay. And then we'll bring in our LED, and we'll just place it down here. Let's go ahead and rotate. Mirror it. Okay. So our jumper cable situation on this one is a little bit different. All right, we're going to essentially go from right here on this leg to the first leg on our second cable. So we're kind of bypassing this connection right here for now. Let's go ahead and change that to purple. All right, then we're going to go from the 2A leg, and we're going to go all the way down to the first leg of the LED. So 2A to the first leg of the LED. All right? And then we're going to go from the 2A leg of the second button also to the first leg of the LED. And then using a black jumper cable, we will ground it to the negative. Now if we run our simulation, our light turns on when we press the first button. Our light turns on, or it doesn't turn on when we press the second button. Oops. I don't know if we can figure out why. Let's zoom in. Right here's our problem. So we don't have this in the right hole. So we'll just scoot that down. Then we zoom back out. Start simulation. And there we go. Either one works. So with that, if I remove this guy, then this button still works. And if I put this guy back in, it was right here, yeah. But I remove this one, then this button still works. So parallel circuits, they introduce a redundancy into the circuit. They're a little bit harder to set up and sometimes harder to draw and then do the math with, but that's fine. Parallel circuits, they are the reason why modern Christmas bulbs don't all go out whenever one goes out. Parallel circuits are great. All right, well, that's enough chit-chat about Tinkercad. Let's build the thing. Before we build, I wanted to take a gander at the wiring diagram. So over here on the left, we have our series, and over here on the right, we have our parallel. So with our series, it's a little bit longer than it needs to be, admittedly, but it's okay. we run through a 220 resistor, then we get to our first push button, then our second push button, and finally our LED. So with our series, we have to push both of these buttons in order to make contact for the LED to turn on. If we push this one, nothing will happen. If we push this one, nothing will happen. They both have to be pushed at the same time. So I have two things that can fail here, which is a failure to push a button. Then over in the parallel, I have kind of the same thing, where I have my 5 volt running through my 220 resistor, but then it comes across the junction. So here is one of my push buttons. If I push this guy, the LED comes on. However, if I don't push this guy, but I push this guy instead, the LED will still come on because current can flow this way, or current can go down here, then up, over, down, and then through the LED. So this is just a quick look at some very bad wiring diagrams about these circuits. So let's go ahead and build them. Right. So let's go ahead and build our circuits. We're going to need a few things: a breadboard, 2 buttons. I like these buttons. They're quite nice. They have, well, let's get in the frame. They have the long legs on them. They're not like those big, bulky buttons. We'll need a 220 resistor. That's seen better days for sure. Some jumper cables, a nondescript amount. An LED. Today we're using green. And then Arduino and cable for our 5 volt power source. So let's go ahead and rig up the first one, which was the series. So I'm going to start by taking my resistor and bending it so they'll slot into my breadboard. Oh man, this thing is rough. Look at that. All right, so I'm going to put it. Let's see, I'm going to go up to the top. So this is my A, B, C, D all the way through. I'm going to put it on my positive and then slot it right over to A1 so that it looks like that. I won't focus, but there we go, maybe. Okay. So then I'm going to take my 2 buttons, and there's 2 ways I can put the buttons in. I can put them in like this, where I have the legs on either side, right here and right here. But if I do that, then I'm essentially just creating a wire, because this leg is directly connected to this leg. So that just creates a wire. So instead, what I'm going to do is I'm going to put them such that they run like this. So leg right here. There we go. It's going to look like that. There we go. I'm going to put my other button a little ways down and just the same. Alrighty. And then I'm going to take my LED. I have a green one today. And I'm going to put it like this right here. So this is our basic setup. We don't have anything wired yet. That's okay. We have our resistor, a button, and an LED. How fun. Okay. Keep it with convention. I'm going to make my red wire my positive. I'm going to make my blue wire my ground. All right. And we'll take care of those here in a little bit. Let's go ahead and connect our buttons. So I'm going to connect from, let's turn it around. I'm going to connect from my resistor, that row, because remember that row is energized. Connect from that row to my first button leg. Let's move these buttons this way since we're doing this orientation. There we go. To my first button leg. All right. And then I'm going to take another wire and connect it to the second button leg, and then connect that to this leg. And then we're going to connect this leg of this button to the leg of our LED. And finally, we're going to ground our LED. So we should end up with something that looks like this. So we have our resistor, and then we have, let's remove these real quick. I mean, that was really bad for the wires. Don't do that. We have our resistor, and that resistor is connected to the button. And then we have another wire jumping from the second leg of the button to the first leg of the second button, and then from the second leg of the second button to the LED, and then from the LED to the ground, which should complete the circuit. So we're going to put our power wires back in. Okay, we're going to look at our Arduino, that's what it's called, and we should see, let's see if we can focus this a little bit. We should see that we have a ground and we have a 5 volt. We're going to plug our negative cable into the ground. Always plug in the ground first, and then our power cable into the 5 volt, such that it looks like that. And then we're going to plug this guy in, rotate just a little bit, finagle, and plug it in. And our Arduino comes to life. Let's see if we did this correctly. So if we did, then this green LED, not this one, let's cover that. This green LED should turn on. If I press one, nothing. If I press another one, nothing. Just like how we talked about in our wiring schematic. If I press two, then we get nothing. Wow. So what's the easiest thing to do here? Well, flip the LED. That's right. Okay. Let's try it again. Hey, we get light. Look at that. If we press one, nothing. If we press two, nothing. There we go. So now, ideally in a real series circuit, you're not going to have two buttons you have to press at the same time. This is just for demonstration as we talk about the parallel circuit. Okay, for our parallel circuit, we're going to be using pretty much the same stuff. We have a few more jumper cables, but that's okay. So let's start out by bringing in our resistor again. We're using a 220. And I'm going to plug in a little bit lower this time. That has nothing to do with this circuit. It's just a personal preference. All right, so I'm going to plug it in right there. We go from if positive. Man, maybe there's a reason why this is in bad shape. It sucks. So we're going to go from positive to right here. There we go. Again, very simple resistor bridge over and out. Okay, so then we're going to once again bridge our buttons. Well, we didn't bridge them last time. So what I mean by bridge is we have this gap right here in the middle of the breadboard. Let's see if we can. There we go. We have this gap right here. So this side can talk all throughout this row, and this side can talk all throughout this row, for example. However, they can't crosstalk unless we jump them. So we're going to jump the bridge using our button. So we're just going to put it right there, and it is now has two legs on one side and two legs on another. We call that jumping the gap or bridging the gap. Okay, we're going to do that with both of our buttons. Maybe. You ever get a stubborn button, just yell at it, I guess. All right. So now we have our two buttons, our resistor. All we're missing is the main thing, which is our LED. Okay, so let's go ahead and put our LED right here. There we go. Okay, so this time we're going to start similar to how we did with last time. We're going to go from right here, our resistor, to the first leg of our button. Then we're going to go from the first leg of our button, right here, to the first leg of this button. Oh my goodness, there we go. Let's make it in the same column. So it kind of looks like that right now. Kind of like that. All right. Then we're going to go from the second leg of our first button. Let's put it in the same row. To the leg of our LED. All right, so far so good. And then we're going to go from the second leg of our first button to the leg of the LED. And then finally, we're going to ground our LED. You're grounded, which just means plug into the negative power. Now, so this is our wiring diagram. Pause the video if you need to. Take a gander at it. There we go. There's a better view. All right. So the reason I moved the resistor down was because I want to have my my power cables up here because I think that would be neat. Once again, we're going to plug our ground in first, like so. And then we're going to plug in our 5 volt, like so. Let's move the ground over. There we are. Now, if this is plugged in and I remove the ground is energized. So we don't want to do that. Whenever you're plugging it in, always plug in your ground first, then your positive. And whenever you're unplugging, always unplug the positive first, then the ground. So let's go ahead and plug this in. We will just plug this bad boy in right here. And then rotate it a little bit just to make it a little easier. I'm gonna plug it into a power source. I have a 5 volt power USB source over here that I'm using, and that's where the charge for this is coming from. Okay, so if I press one button, nothing happens. Press one button, nothing happens. Likely issue, switch out the LED. Oh, look at that, how fun. All right, let's see if we can figure out what's going on. There we go. All right, so I don't know what it was. Maybe this part of the breadboard just doesn't like me, but it's right here. It's a no-go. But if I move it closer, it's also still a no-go. Oh, okay. I figured out the problem. The resistor is loose. So we press this button. Oh, let me get my finger out of the way. Press this button works. Press this button works. Press both of them. Still works. So this is a parallel circuit. If I remove this button, but press this one, it still works. See if I can put it back now. If I remove this button, but press this button, it still works. So what I'm doing is I'm reducing the amount of faults that can happen within my circuit. I'm introducing a redundancy. So I could press both if I wanted to. It's not really going to do anything. It might heat up the wires a little bit, but other than that, we now have a parallel circuit.